Hey, hello there, welcome to CS School channel. In this video we are going to look at searching in the sorted rotated array. Okay, this problem is asked a lot of time in different coding interviews. As usual, the link of this problem is in the description of this video, so do check it out and try to solve it on your own. If you couldn't solve it, come back to this video. Now let's look at the problem statement which is given on the screen. Given the sorted array nums after the possible rotation and an integer target, return the index of target if it is in nums or -1 if it is not in nums. Basically we need to search the target in the numbers array, but there is a small condition that is given here. The array is actually sorted and it can have a possible rotation. Okay, the expected time complexity is O of log n. Okay, so here is the first input. The array which is given to us is 4 5 6 7 0 1 2. Okay, so if you rotate this array by 3 positions, you get 0 1 2 4 5 6 7, which is kind of a sorted array. Okay, so what they have done, they have taken a sorted array and they have rotated it by 4 places. After that we get this array and we need to find this target 0 in this array, and the output is 4 because the index of 0 is 4. 0 1 2 3 4, right? So that's how we have found output 4 in this example. The second example is this same array with the target as 3. As 3 doesn't exist in the array, the output is -1. Similarly, in the third example, the array which is given to us has only one element and we need to find target 0, and again we are returning -1 as the element doesn't exist in the array. Okay, so hope you are clear with the problem and the sample inputs and outputs. Now let's start with the first approach, which is a linear search approach. Okay, so in this approach what we will do, we will start iterating over the each elements of the array. Okay, so we will start with 4. We will check, is 4 matching with the target? No, right? Then move on to the next position. Compare 5 with target, not matching, move on to the next position. Compare 6, not matching. 7, not matching. 0, now it's matching. Okay, so that's when we have found our element and we just need to return the index of this element. Okay, so we will take a variable I which will be initialized with 0 and it will rotate over the entire length of the array, and whenever we found the target we will just return the I. Okay, so what's the time complexity of this linear search approach? Well, the time complexity is O of n. Why n? Because we are iterating over the entire array. Okay, so at max we can iterate over the n elements, so that's why the time complexity is O of n, and space complexity is O of 1 because we are not using any extra space. Cool. Now let's see how we can optimize this approach to solve this problem in O of log n time. Now let's think about what can be the efficient solution for solving this problem. Okay, so see, this is a searching problem. Okay, we need to find a target inside the array and the array is sorted some way. Okay, there are some small changes in the array, but at the end array is sorted, right? So which is the algorithm which helps us in finding a particular element in a sorted array? It's binary search, right? So can we use binary search here? That's what you need to think about. Well, actually we can, and there is a way to use it. Okay, so before solving this problem, the prerequisite is the binary search problem. Okay, so there is a video out over on channel. The link of that video you can find in the description of this video, so do check it out, see it before you continue to this problem. So now let's see how we can use binary search in this problem. Okay, so what is the first step in binary search? It's actually calculating the mid. Okay, so which is the mid in this array? Well, it's 7, right? So now tell me, is the array including this 7 and before this 7, is it sorted? Yes, it's actually sorted, right? 4 5 6 7, right? Is the array after this 7 and to the end, is it sorted? Well, it's also sorted, right? Correct. Now consider this 5. Okay, so is the array before and including 5 to the start of the array, is it sorted? Yes, it's sorted, right? Now tell me, is the array after 5 and to the end of the array, is it sorted? Well, no, actually it's not sorted. So see, 6 7 it is sorted, but after that the number should increase, but it is going to 0 1 2. Okay, so this part is sorted, but this part is not sorted. Now let's look at for 6. So is the array before 6 sorted? Yes, this array is sorted, but this part again is not sorted. Okay, so this part is sorted actually. Now let's look at for this 0. So is the array until 0 sorted? 4 5 6 7, but it is the 0 is coming after 7, right? So this is not sorted. Is the array after 0 sorted? Well, it is sorted, right? So this is the sorted part. Now let's consider for 1. So is the array till 1 from the start sorted? Yes, it is sorted. And is the array after 1 sorted? Well, it is also sorted because there is only one element, right? So by observing this, you will see that at least one part of the array is always sorted and the other part of the array can be sorted or cannot be sorted, okay? And it can be a left part or the right part, okay? So this observation will actually help us in solving this problem. Now one more thing that we need to see is to find out how to check whether a particular partition is sorted or not, okay? So let's say we have made a partition here, okay? Now how do you know this partition is sorted and this partition is not sorted? So you can clearly see that this partition is sorted and this is not properly sorted, okay? So for that, what you can actually do, you can compare the lowest and the highest point in each of the partitions, okay? So if you compare 4 with 6, 4 is lesser than 6, okay? But if you compare 7 to 2, 7 is actually not lesser than 2, right? So a partition is sorted if the array of, let's say, low is lesser than or equal to array of mid, okay? So considering this is the low and this is the mid, okay? And similarly, so basically this is the condition for left hand side of the partition, okay? And how do you know if the right hand side of the partition is sorted or not? For that we can do something like this: array of, let's say, mid plus 1 is lesser than or equal to array of high, okay? So if this condition is satisfied, the right hand side of the array is also sorted, okay? Currently this condition is not satisfying because 7 is not lesser than or equal to 2, okay? So the left hand side of the array is sorted and the right hand side of the array is not sorted. So these are the two conditions that you need to remember to kind of find out whether the left hand side of the array is sorted or the right hand side of the array is sorted. Okay, so now we have understood how to find out whether a particular partition of the array is sorted or not. Okay, now given that a particular partition is sorted, can we definitely say whether that target exists in that partition or not? Actually we can. Okay, so consider that this partition is perfectly sorted, this 4 5 6. Okay, can we say that target will exist in this partition? Yes, actually we can, right? As this array is sorted, we know that the elements within 4 to 6 will exist in this partition, right? As 0 is lesser than 4, this element cannot exist in this partition. Okay, consider if the target would have been 5. In that case, we could have said that 5 is actually greater than 4 and it is lesser than 6, right? Let's make it greater than or equal to. So we can definitely say that 5 will exist in this part of the array. Okay, but as our target was 0, we can say that 0 is not actually greater than or equal to 4 and lesser than or equal to 6, right? So 0 cannot exist in the left hand side of this array, right? So when we found out that, we can just discard this part of the array and start searching in the right hand side of the array. As right hand side is not sorted, we need to find the mid again. We need to see which part of the array is sorted and we need to again do this operation. Okay, so that's how actually binary search will be applied in this problem. Now we have all the building blocks for solving this problem. Now let's look at how to use those building blocks and to apply these building blocks in actually solving these problems. Now let's solve this problem. Okay, so we have taken two variables, low and high. Low is pointing to the first element of the array and high is pointing to the last element of the array. Okay, now in the binary search we need to find the mid. Okay, so if you calculate the mid, it will come to 7. Okay, just sum up low plus high. High is, I guess, 7 here or 6. Okay, so 0 plus 6 divided by 2, it will come to 3. Okay, so this is the element at third position. Okay, now you need to check which part of the array is sorted. So this is the first partition, this left hand partition, and this is the right partition. So after calculating the mid, we have actually made two partitions of this array. This is the left hand side partition and this is the right hand side partition. Now we check first, is the left hand side partition sorted? Well, it is, right? So 4 is actually lesser than or equal to 7, right? So left hand side is perfectly sorted. Now we need to figure out whether this 0 exists in the left hand side partition of the array or not. Okay, for that we can make this comparison. 4 should be lesser than or equal to 0 and 0 should be lesser than or equal to 7, right? So this condition is not actually satisfying, right? 0 is much lesser than 4, right? So our element actually cannot exist in the left hand side of the array. Okay, in this case what we will do, we will update our low to be mid plus 1. Okay, so now our low has come here. Okay, so low has reached here. Now let's just repeat this process again. Okay, so now our low is 4 and high is 6. Okay, what will be the mid? The mid will be 6 plus 4 divided by 2, which is 5. Okay, so this is the mid now. Okay, now we check whether this particular part of the array is sorted or not. So we compare array of low is lesser than or equal to array of mid, right? As 0 is lesser than or equal to 1, we know that this part of the array is sorted. Okay, so again we check whether 0 can exist in this part of the array or not. Well, as 0 is lesser than or equal to 0 and it's smaller than or equal to 1, basically this 0 exists in this range, we can definitely say that target is existing in this part of the array. Okay, now what we do, we update high to be mid minus 1. Okay, as our target is existing in the left hand side of the array, we are updating high to mid minus 1. Okay, so let me just do that. Okay, now this is the only partition and partition with only one element remaining to be checked. Okay, we will calculate mid again. Okay, now mid is like similar to low and high. Okay, then we check whether the element at mid is equal to target or not. Well, the element is actually equal to target. Okay, so we can return the value of mid here. Okay, and we are done with the algorithm. So basically you check whether the element exists in the left hand side of the array or right hand side of the array, and according to that you perform the operations on each of the part of the array. Okay, and in each of the iteration you actually discard half of the array. Okay, so what's the time complexity? As we are using binary search only, a modified form of binary search, the time complexity is O of log n only. Okay, and what is the space complexity? As we are not using any extra space, the space complexity becomes O of 1. Okay, so hope you are clear with the algorithm which we have used to solve this problem. Now let's look at the C++ implementation of this problem. So this is the C++ function search, which accepts vector of integer nums and a target as an input, and it expects the position of the target as an output. Okay, so similar to binary search, we have initialized two variables, low with 0 and high with size -1. Okay, and this is the while loop. While low is less than equal to high, we have calculated mid. Okay, low plus high divided by 2, and after that we have compared whether the number, the target, exists at the middle position or not. If it exists, we are directly returning the mid. If the target doesn't exist at the position of mid, we are first checking whether the left hand side is sorted or not. So this is the condition to check whether left hand side is sorted or not. Okay, if it is sorted, then we are checking if our target actually exists in the range of the left hand side. Okay, as we have seen in the previous example. So if our target actually exists in the range of the left hand side, then we are moving our high to mid -1. Okay, so in this case we are completely discarding the right hand side part, and we are saying we will be focusing on this left hand side and we will be performing binary search on this left hand side. Okay, if our target doesn't exist in the left hand side, then we are moving our low to mid +1. Okay, so in this case we are completely discarding the left hand side part and we are completely focusing on the right hand side part. Okay, as our target doesn't exist in this range. Okay, but what will happen if our left hand side is not sorted? Then we move to the right hand side. Okay, we know for sure that our right hand side will be sorted. Okay, so we are checking that if our target exists in the range of the right hand side. Okay, so we are comparing with mid and high. Okay, if it exists, we are moving our entire focus to the right hand side by setting low to the mid +1. Okay, now if our target doesn't exist in the right hand side, that means it will exist somewhere in the left hand side, right? So in this case, we are setting high to mid -1. Okay, and at the end, if it doesn't found our answer, we are returning -1. Okay, so hope you are clear with this entire algorithm. Now for running this code, I have written a main function which has defined vector of nums, and it has called this search function with a target as 1. Okay, so 1 exists at the 5th position. Now let's run this code. Okay, so we get 5 as the output, which is the position of element 1. So hope you are clear with the problem and its possible solution. If you have any doubt, do ask me in the comment section. I will be more than happy to help you. We will be making more such videos in the future, so stay tuned for further updates and do subscribe to our channel. It helps us to stay motivated and make more such content. Thanks for watching.